we'll be immediately able to see that once I end the heat after going on and starting up the next heat, these entries will give us a number about how much was the metal observed and how much of metal was produced by the entry of these billets alone. So I'll just go up and close it over here. As you can see, total actual billets which were observed and which were marked in this particular heat were 41, which equals to a total amount of 17 tons of production of billets, out of which 35 billets were entered good, so they were passed on to the rolling mill, and only 6 billets were bypassed, which amounts to a total of 2.48 mt of production. So this is the complete closure of the caster system. Now moving on to how the rolling mill system works, we'll just shift from the caster tab to the rolling mill tab. I'll go back from here. Once I go to the rolling mill section now, the rolling mill supervisor will be able to see only this much section of data. Now he just has to go into the rolling mill production form, and as soon as he enters, he'll just have to click on the start button of the heat. Once I start the heat from here, I can select it as a blue box, select the TMT size which we are supposed to roll. As we selected 12 there, I'll also select that we have to roll 12 of TMT final TMT product. So a CRS 550 grade 12 TMT bar will be rolled is what I am telling the system. It will hence record the size wise records in the rolling mill dashboard that 12 has been rolled. I just start the heat over here, and the timer has now started. Once the timer has started and the process has started, again the operator from the rolling mill only has to specify how much of billet rolling has been completed. As 35 billets were passed on to the rolling mill, the billet operator will now, the pulpit or rolling mill operator will add an input size of 12 again over here. This size will be the size of billet that was received to the rolling mill and that has been passed through the entire rolling mill section, because it will decide the overall weight that has been added to the rolling mill. Now, as you can see, we have accepted a 12 175 section billet, and so I'll just go to the accept and bypass reasons. Here, similar reasons are available. Now, suppose the rolling mill in charge, the rolling mill supervisor observes that there has been one rhombodity case and they have rejected one single billet due to a rhombodity, which is caused by the CCL out of those 35 billets, and then they have passed on or they have rolled the other 34 remaining billets. They'll go on to save this section, and once this is saved, again the drill for mentioning the operator and mentioning the supervisor continues. Once this is done, they will simply go up, come here and end the heat for that rolling mill. Hence, we can see that a complete end-to-end process from furnace, caster to rolling mill, all three of these different inputs, including the quality of the furnace heat produced, has been entered, and with an explanation of how the entries from different types of operators will be done. Now, once these operators are trained, and as you can see, the UI of this is very easy to understand, very easy to operate, even for a layman operator. So, training and entering data will not take much of their time, and critical processes of production will not be hampered by the additional use of Connectfacts. So this is just more or less like replacing a digital, replacing the physical copy or a physical logbook that they maintain with a digital one. So moving on to the other module of Connect.